Hi everyone, welcome back. We're going to be finishing off 2.7. Today in class we looked at confidence intervals for proportions, and as promised I'm going to finish that lesson for you so that we can focus on reviewing for the midterm on Tuesday. So we need to look at the conditions for confidence intervals for proportions. So just like with hypothesis testing for proportions, the samples have to be randomly selected. The population should be greater than 10 times the sample size, or 10 times n, so that's your 10% rule. And then the success failure rule is the one that's slightly different because remember we don't know our parameter p. So we replace p with p hat when we're doing success failure. So that's the biggest difference. So if you'd like, you can pause the video and read the problem under the try these, and then we'll work this out together. It says there are many websites devoted to science fiction. Science fiction books, television, and movies focus on imaginary stories on topics like outer space and futuristic technology. A science fiction website made an important announcement. The announcement was about college students' beliefs about extraterrestrial aliens. The website claims that the proportion of college students who believe that extraterrestrials have visited Earth is equal to 0.06. Suppose you wish to investigate this claim by doing your own study of a randomly selected sample of Valencia College students. You take a random sample of 200 Valencia students. You find 45 believe that extraterrestrials have visited Earth. So first we want to look at our sample, which consisted of 250 students. So that's our n, right, our sample size. And we know that 45 believe in extraterrestrials visiting Earth. So that's your x. And when I want to figure out p hat, my sample proportion is just x over n. So here it's 45 over 250. And if you divide that, you get 0.18. So that's my sample proportion. 18% of my sample believe that extraterrestrials have visited Earth. So we need to verify the criteria for approximate normality, and we need to make sure that it's random, which it says right here, a random sample of 250 Valencia students. We need to check the 10% rule, which says that our sample can't be more than 10% of the population. So I just do 10 times n, or 10 times 250. So that's 2,500. And then the last one is n times p hat. That's my success. So that would be 250 times 0.18, which has to be greater than or equal to 10. And that gives me 45, which is greater than or equal to 10. And then 250 times 1 minus 0.18, or 250 times 82%, also greater than or equal to 10. That comes out to 205. So yes, the conditions for normality are satisfied. Okay, so I can use a normal model, which is important here for investigating the parameters. So the true percentage of Valencia students who believe that extraterrestrials have visited Earth. Okay, so I need to find the standard error. And to do that, remember, I'm using the same formula I used for hypothesis tests, except instead of p, I'm using p hat because, again, I don't know p. So you're just going to substitute your numbers in here. P hat is 0.18. 1 minus 0.18 is 0.82. And I'm dividing by my sample size, which is 250. Okay. When I do that, I end up with 0.0243. So that's my standard error. Okay. To find the margin of error, so remember, we're looking for 98% confidence, right? So to do that, I need to find my critical value, my ZC. And to do that, I need to do inverse norm, which remember on your calculator, you can get from going to second vars and then choose number 3. So it's inverse norm, and we want to use, so 98% from 100% leaves us with 2% divided by 2. So that's 1%. If I plug in 1% though, it's going to give me a negative. So instead I'm going to plug in 100 minus 1, or 99%, the top 1%, in other words. And when I do that, I get 2.33. That's my critical value. I need that because I need to multiply the critical value times the standard error to calculate my margin of error. So when you do 2.33 times 0.0243, you get 0.0566. So that's my margin of error. Okay, so that means that I'm going to take my sample proportion and I'm going to add and subtract that value to come up with a range of values to kind of target where my proportion is, my population proportion. So in number 15, it says interpret the margin of error and what it means in context of the problem. So it just means that the percentage of all Valencia College students who believe extraterrestrials have visited Earth is 18% with a margin of error of 5.7%. So that means it's 18% plus 5.7% and minus 5.7%. I'll just call them ETs, okay? Extraterrestrials have visited Earth is 18% with a margin of error of 5.7%, right? If you take 0.0566 and change it to a percent, just move the decimal over 2 places to the right. So if we round, it's like 5.7. So now to find the 98% confidence interval, I'm going to take my p hat and I'm going to add. So instead of writing 0.18, let's just do 18% plus or minus 5.7%. So if I do 18 minus 5.7, I get around 13.3%. And if I do 18, so wait, that's not right. 18 minus 5.7, so it should be like 12.3. And then 18 plus 5.7 is 23.7%. So we would just say we are 98% confident that the percentage of all Valencia College students who believe extraterrestrials have visited Earth is between 13.2% and 22.8%. So our sample said 18%, but we know that if we took another sample, that may not be the case. We might get something lower than that, but we're 98% confident that the true percentage of college students who believe that extraterrestrials have visited Earth is somewhere between 13.2 and 22.8%, which also means if I was to take 100 random samples, 98% of them would capture the true proportion of all students who believe that. So now the website claims the proportion of college students who believe that ETs have visited Earth is equal to 0.06, 6%. What do you think about this claim based on the confidence interval? So if you look at your confidence interval, 6% is not in between 13.2 and 22.8. In fact, it's kind of far from 13.2. So I would say that that's not very likely. And there's a lot of things that could have contributed. It could be there could be an error in the data, or maybe they didn't take a good sample. Maybe it wasn't random. So it's not likely because 0.06 is not in our interval. Okay. So the next part of the notes involves looking at how increasing the sample size, what that does to the margin of error, and also to your interval. Okay, so if you notice here, as you start out at 830, your sample size, and you increase it to 3,320, what do you notice about the margin of error? Okay, so as this is increasing, 830 to 320, this ends up decreasing. So if you increase your sample size, you end up decreasing the margin of error. Okay, and also if you look at your confidence interval, is it getting wider or is it getting narrower? So if you start out with 830 in your sample and you look at your confidence interval, it goes from 34.6 to 41.4. So it's about 7 percentage points away from each other. But if you go down to 3,320, now your interval is only about 3% away. So the key here is to have a large sample, because a large sample size will lower your margin of error, which will allow you to hone in on what the true population parameter is. Okay. So we're just going to say, if I was to sum this up, the big picture here, keeping confidence the same, if you increase your sample size, which is n, and decrease the margin of error, it will make the interval smaller and more precise. Which is the key, because that will allow us to get closer to the population parameter. And what I would like you to do is, if you go into Canvas, into the assignments, I put an assignment in there. It has to do with confidence intervals. It's under ungraded assignments, but it's going to take you to a website that looks like this. And what I would like you to do is play around with the confidence level and the sample size and notice what happens. And then you can fill out numbers 18 through all the way down to 25. And kind of get the big picture of what's going on. So you can use the sliders to change your confidence level. You don't really have to do anything to the population proportion. You could just leave that. But if you were to keep your confidence level at, let's say, 95% and your sample size at 20, right? Our goal is to have that interval capture the population proportion, 0.5. So if I hit sample, it shows that my interval goes from somewhere a little lower than 0.30 all the way up to somewhere a little past 0.70. That's a large margin of error, right? That's showing my margin of error is basically 0.22. So it goes from 50% to 22%, and then 50% minus 22%. That's a large interval, okay? And if you keep clicking sample, you'll see here how many of these intervals actually capture the true proportion, okay? Now, what would happen if I change my confidence, let's say, to 99%, right? You can see that the interval just got wider. Now, what happens if I lower my confidence? Now I'm not as confident, but my interval got smaller. And also notice, though, that one of the intervals didn't capture the proportion. So what we want to do to fix that is we want to increase our sample size. And you can keep your confidence level the same. And now when you go to click sample, you'll see here that there's quite a few that have captured the true proportion. Where that green line is, that's where those intervals are capturing the true proportion, and the red ones have not. But there's more that have captured it by increasing the sample size. And actually, you can take your confidence now too. And notice when I increase the confidence even, I'm getting more accurate. Okay, so you can play around with that, and then you can fill in the rest of the problems, numbers 18 onward. But I'll fill those in for you now. So basically, after you play around with the applet, and I strongly suggest that you do, because it'll help you discover what's going on and how all of these things like sample size and margin of error and the proportion and the interval are all related. So increasing the sample size will cause the margin of error to decrease, and it will create a narrower. Here, I'll highlight this instead. It'll be easier. So it's going to cause increasing the sample size will cause the margin of error to decrease, and it will create a narrower, more precise interval, which is what we want, right? This is our goal. Decreasing the sample size will cause the margin of error to increase. It will create a wider interval, and it will be less precise, which is what we don't want. We don't want to increase our margin of error. Making our interval wider is going to, allow us to be able to capture the parameter, but it will also make it less precise. So it would be like looking for, a missing person on the Valencia downtown campus versus, let's say, a larger campus like UCF, right? You have a better chance of finding them at the downtown campus because it's smaller than finding them at a larger campus. For number 19, if you increase the confidence level, it will cause the margin of error to increase, and it will create a wider and less precise interval. Decreasing the confidence level, hopefully you saw in the applet that it will cause the margin of error to decrease. It will create a narrower and more precise interval. Okay, so again, here's the other key. We want to decrease the confidence level as well. Decreasing your confidence and, increasing the sample size will allow you to capture the target. Okay, so looking at the above statements, which two options would lead to a more precise interval? So it would be the ones where I started. You would want to increase your sample size and decrease your confidence. What option do you think is preferable? So we would want to increase our sample size because we would like to be more confident. We don't want to decrease our confidence. So we kind of, find a happy medium, which is increasing the sample size. And don't play around with the confidence level. It's kind of like if I said to you, oh, the test scores range from 0 to 100, but I'm 50% certain you got an A. That's not as, that wouldn't make you feel as confident as saying, okay, the test scores go from 0 to 100, but I'm 95% certain you got an A, right? So you don't want to decrease your confidence, but you do want to increase the sample size. Okay, and you can play around with all the other ones and write down what you notice from each of these, and make sure you read through all of this. Okay, I want to skip ahead now and go to number 27. So write a sentence explaining what 98% confidence in the context of this problem is by filling in the blank. So again, we were dealing with extraterrestrials, right? So 98% confidence, what that means is if we were to make 100 confidence intervals at the 98% confidence level, we would expect 98 out of the 100 random samples to actually contain the true percentage of all, because we're trying to find P, Valencia College students who believe extraterrestrials have visited Earth. In the original problem, it stated that you took a random sample of 250 Valencia students and you found 18% of them believe that extraterrestrials have visited Earth. Do we know for certain the percentage of the selected sample falls in the 98% confidence interval? Well, our interval went from 13.2% and 22.8%. So we are 98% confident, not 100%, but 98% confident that the true proportion falls in between that interval. Okay, so that sums up the rest of the section 2.7, and that is the end of what will be on the midterm. Make sure you read through the summaries. Make sure you've done homework. Try the problems where there's answers given, and then you can always ask me to go over those in class next week, or reach out to me. Hope you all enjoy the rest of your day.